Today we're going to talk about solder and how it is holding everything together. Now, admittedly, this is a subject that I don't have a lot of experience in, so I am actually really excited about talking to our guest today to get a better understanding of where solder is used, how it's used, what the differences are in performance characteristics from one type to another. We're really going to go deep on this subject, so I'm really excited. I think you're going to enjoy it as well, because as always, we're going to tie this back to how it will help commercial vehicle owners lower their total cost of operation by making sure that their repairs and the products that they are buying are high quality and lower that cost of operation and that total cost per mile. So let's bring our guest on. My guest today is Aaron Morrow, the general manager at Johnson Manufacturing Company. Aaron, welcome to the Heavy Duty Parts Report. So glad to have you here.
Well, good afternoon. I'm doing well. I hope you are too.
I certainly am, and I'm happy you're here. So, Aaron, we got to meet a couple months ago back at the Apex show, and I've been anxiously waiting to have this conversation with you. So let's get right into it. What is the difference between solders and fluxes?
Absolutely. So those are the two main products that we sell here, and they're very different. Solders are metals that are used to join two base metals together. We make those by taking different elements like tin, lead, copper, antimony, silver, bismuth, and in different percentages, mixing those together, heating them up, and forming a new alloy. And then that goes on to become bar, wire, whatever you need for the application to join those base metals. The fluxes, on the other hand, are liquids. Those are chemicals. Usually they're acidic, and those are used during the soldering process. So the flux can be applied beforehand or during the soldering process. And what that does is clean the oxides off the surface of the base metals so that when the solder melts and flows, it's joining to clean metal and getting a good metallurgical bond. The other thing the fluxes do for you is act as a shield for that solder when it's in its molten state so that you're getting the best bond possible.
Okay, so where is the solder and fluxes most dominantly used when we're talking about commercial trucks, big diesel, semi-trucks? What are the most common applications?
So the place that you're going to find the most solder is any of those electrical or circuit board components. So anything on a truck that can hook up to a diagnostic or has a circuit board in it, all of those are assembled using solder or solder paste to put those things together. But that's not the only place that you're going to find them. The heat exchangers that are in your truck are put together by solder as well, especially if you're talking copper brass. Those have joints where the fins meet the tubes. Those are soldered together. Where the tubes meet the header, those are soldered together. And again, where your tank meets your header is soldered together. In all of those cases, the solder is either providing a connection for heat transfer or electrical transfer, or acting as a seal or a way to join something so that it stays together. Those are kind of the biggest places, but you may even find it on the outside of the truck. There's solders that are used for repairing body panels that can be used to fix something in the physical outside of the vehicle.
Oh, interesting. So electrical, mechanical, and also on the body. So basically, when we say solder is holding everything together, that's not really far off.
Correct.
So I was looking at your website and I saw that you had some different types of solders. So for example, I saw the expression tin lead and lead free. What's the difference and what drove the innovations around the different types of solders?
Absolutely. So the original solders that would have been developed would have been those tin lead solders. You think back to early craftsmen that would have been taking metals that they found in the earth, and they find that as they mix them together, they can hold things together that don't come apart. And so tin lead would have been your rudimentary beginning stages of that. Tin being the magic ingredient in most solders. So tin is the one that will dissolve other metals and hold it in solution to create other alloys. If you think way back in the day, they made things like bronze and brass by mixing different metals together. Solder is the same kind of concept. We choose which elements to add into a solder to change the properties of the solder for the end use that we need. Things like silver can add strength and change your temperature profile. So tin leads were the beginning that went everywhere.
Let me just ask you a question. My daughter, one time we said the dress she had on made her look like Olden Days. And she was like, "You mean like 1999?" And we were like, "Well, no, we were thinking more like 1899, but yeah, okay." So when you talk about back in the day, how far back are we talking?
Absolutely. So tin lead is probably the basic solder that started hundreds and hundreds of years ago.
Really though, like hundreds of years ago?
Yes.
So like chainmail and like knights soldering like what were they using it for?
They would have been using it to join things together just like we do
Wow.
today, but they didn't have the science to really fine tune what they were doing. They just knew what they could mix together to hold things together.
That's really cool.
You know, there's people even today that do tinsmithing as a hobby, where they will make things like cups out of tin sheet metal that they're soldering together using things that might have been done in the 16 or 1700s. As those things have evolved, some of those tips and tricks and applications have still stuck around now as a hobby in those areas, but we're using solder everywhere in our everyday lives. We're coming into contact that have solder connections in them. Every piece of electronic equipment that you use has that circuit board, and those circuit boards are put together using lead-free solder. And that and plumbing were some of the big innovations over the last few decades. What we learned was that lead is not so good to have in some places. So, like your potable water systems, it's bad to have lead in there. And over the years, the plumbing industry has switched to using nothing but lead-free solders for potable water systems. Electronics made a switch very similar to that back in the 90s, mainly because a lot of these electronics were ending up in landfills, and that lead was leaching out of the discarded electronics and making its way into the groundwater. And so part of what they sought out to do was to get the lead out and replace it with lead free. And so there was a lot of studies into which solder alloys needed to be developed to give similar characteristics to those tin lead solders that work so well, but provide some of the safety by taking the lead out of the solution.
Boy, that is fascinating. So that issue, that safety issue of things leaching into our groundwater and affecting our environment. Like for example, even with friction material on commercial trucks, they had to change the composition of it a few years ago because one of the compounds that they were using was no longer allowed, and they were worried about it leaching into our groundwater. So I guess we should be happy that they've made those changes, and it's been, I'm sure it was a bit of an adjustment on the manufacturing side to introduce some of these new products, but these are pretty stable products that have been in use now for quite a few years.
Right. I think we're coming up on 3 decades from when these switches really started in the electronics industry, and even farther in plumbing. And so the industry really has adapted to those things. There's been changes along the way, different discoveries that have changed what maybe the alloy of choice is in that industry. But overall, they've stayed lead free and things have adjusted. They found ways to make them stand up to the rigors that they needed to. So if you think like electronics, originally most electronics were pretty stationary. They weren't seeing a lot of vibration like you'd see in a truck, or drop shock like you might see in a cell phone. And as the electronics got smaller and started to be out in the world more, they had to find a way to make sure that the solders could stand up to those vibrations, those drop shocks, especially if you're going to put them on a vehicle. If you have a little fender bender and that means that every circuit board in your truck no longer works, that's not going to help anybody. So they had to find ways to make sure that they would stand up to those things. The other thing they look at is temperature cycling. So electronics run hot, just like our trucks do. And so the electronics and the solder connections need to stand up to feeling that negative 40-degree wind chill in the middle of the Midwest in the middle of winter, up to the hundreds of degrees that they see when the truck is on the road and running hot. while it's moving its load across the country. And it needs to be able to handle those fluctuations and those extreme temperature differences without failing.
Well, this has been fascinating. We're going to take a quick break, but we'll be right back. Don't have a heavy-duty part number and need to look up a part? Go to parts.diesellaptops.com or download the app on Apple or Android to create your free account. Looking for high-quality fuel injection for heavy-duty applications? Having one supplier for fuel injection allows you to better serve customers by providing them with a complete line, which increases your sales and profitability. Learn more at ambackinternational.com/aftermarket. We're back from our break, and before the break, we were getting a lesson on where solder is used and also on how it was developed over literally hundreds of years, which is just fascinating. How do you ensure that the solders that you manufacture are going to perform the best for the customers who use them in that commercial truck application? Before the break, you were kind of talking about the big ranges of temperatures, for example, that trucks operate in, all the way from maybe the desert up to northern Canada, and you're going to get these massive fluctuations. Plus, you also have trucks in so many different vocations. So how do you go about making sure that they're going to be up to the performance characteristics required to keep those trucks on the road?
Absolutely. So at Johnson Manufacturing, we do a few different things to make sure that the material we're sending out is quality material. Beyond making sure that the material is quality, we will work with customers to make sure that they're identifying the correct solder and the correct flux for their application, especially if it's something that we've got experience with or we have customers that have had previous experience. We like to be able to share that knowledge and make sure that they're taking advantage of those lessons that we've learned. What we do to ensure our quality, the first thing that we do is everything that we buy from a raw material standpoint is 100% virgin metal. We don't use any reclaimed or recycled solder within our process. That allows us the traceability to know the source of the material, the quality level of it, and the analysis of it as it comes in. And then we've handled it from there until it goes out the door, so we know what's in it. When we're purchasing that material, specifically the tin, we buy only from conflict-free sources. So back in 2008, the Dodd-Frank Act was passed. And one of the requirements of the Dodd-Frank Act is that all publicly traded companies must declare whether they do not, or they do not know whether they're using conflict minerals within their supply chain.
Conflict, like what you mean is, for example, if there was a civil war in an area, the raw materials were extracted. Is that what you're talking about with conflict, or what does that mean?
So if you've heard of the movie Blood Diamond, it's the same kind of concept. So there are mines for these materials all around the world where they're using slave labor and taking advantage of the people in the region to extract these minerals from the ground, refine them, and then sell them at a huge profit. And so parts of Africa were identified as being major regions of conflict resources. And so the Dodd-Frank Act wants these publicly traded companies to announce whether they do or do not use that material. Johnson Manufacturing is not a publicly traded company, but our customers or our customers' customers are. And so the Dodd-Frank Act had the response that they wanted, which is that this has trickled all the way down through the supply chain to where a small 28-person company in the middle of nowhere, Iowa, is making sure that what we buy is coming from mines that are certified conflict-free. So when we place our purchase orders, we know what's coming in is from one of those mines and has that certification. There's an EICC template that tracks the sources that you're using, not only for metal, but metal powder. And we provide those to our customers as needed to show that we're certifying that everything we're making is conflict-free.
So it all starts with the raw materials, getting the right kinds of materials, and that is what ensures that you're going to be able to produce not only a high quality product, but a ethical and sustainable product.
Absolutely. And we take that to the next level when we go into how we produce the material. So we use a proprietary vacuum casting process here. That gives us a couple advantages. We can do everything as a batch process instead of a continuous process so that we're always monitoring what's happening. That also allows us to do smaller run alloys or harder to run alloys that maybe some other manufacturers aren't able to do. But the way we do this, we've got a vacuum tube that's inserted into the top of the molten solder. Most solder manufacturers are using a bottom tap kettle doing continuous casting. Ours is actually being drawn from just below the molten surface into a tube where it's never seeing atmosphere. So it's being drawn from below the molten surface into a vacuum where it's cooled and hardened, and then it's dropped out and cut to length to go into our extrusion presses. The other advantage this gives us is we're not drawing any oxides into our solder when we're casting. Because we're below the surface, the oxides are on the surface, and we're drawing metal from below. That oxide free then carries through when we start extruding, drawing, and spooling our final products.
Fascinating. That is awesome. So all of this is very interesting, but let's talk about how it impacts the kind of the day-to-day maintenance and repair of vehicles. So do you see any common mistakes that repair technicians make when using solder and fluxes, and how could they avoid those mistakes?
Sure. So a couple little things that we see is not being familiar with nomenclature. So solder is one of those things that not everybody deals with on a regular basis. And we'll have people call in and try to order 60/40 solder because they think that's what they need, but what they're really after is 40/60. And so through the years, we know which industries take which specific alloys, and we try to direct our customers to the correct stuff. When you're naming an alloy, the tin percentage always comes first. So a 40/60 alloy is 40% tin, 60% lead. A 60/40 is vice versa. It doesn't sound like it's a big difference, but in terms of cost, it's going to be a few dollars per pound more expensive for a 60/40. And in terms of performance, it's going to be night and day difference. So a 60/40 alloy has almost no melting range to it. As soon as you get it up to its melting temperature, it's fully molten, fully liquid, and it'll run off your workpiece. Whereas a 40/60 solder has a plastic range where it starts to melt, but it's not fully molten. It gives you a little more leeway while you're working with it to make sure that you're getting it where you need it to be, not to mention those cost savings. The other one that we hear a lot is silver solder. Silver solder isn't actually solder at all. It's a brazing alloy. Brazing and soldering are very similar, but they take place at much different temperatures, and they both require different fluxes to do the job properly. There are solders that are lead-free solders that contain silver. So there are silver-bearing solders. But when most people use the term silver solder, they're referring to brazing alloys. So when customers call in and they're asking about silver solders, we make sure that they understand the difference between silver-bearing solders that are going to melt at 840 degrees Fahrenheit or below, or silver solders that are actually brazing alloys that are going to be up maybe in the 11 to 1400 degree range, and make sure we're getting them the right fluxes for the application that they're using these. There's a big difference in price between those as well. So while a lead-free solder that does have some silver in it is going to be expensive compared to a tin lead solder, they might only have 3 or 4% silver in them. Some silver solders, silver-bearing alloys, are 50, 55% silver. And you can imagine at what current silver prices are, how much more expensive those alloys are per pound. And so we're always making sure that our customers are looking for the alloy that's going to give them the most bang for their buck, get them the job done and done right without having to spend more money than they need on an alloy that maybe has something that doesn't provide benefits for their application.
Speaking of keeping costs down, how does using the right product for the right application lower total cost of operation for people doing repairs on commercial trucks and fleets?
The biggest thing that we bring for cost savings is that if you're putting together a good quality product that isn't coming apart, then your truck is going to be up and running, and that is where you're making your money. Anytime you've got downtime because something needs repaired, replaced, recored, all of those things mean your truck isn't moving and you're not making money. But it goes beyond that. If somebody has made the option to switch from a tin lead to a lead free, while the material may be more expensive and therefore you might have to spend a little more to build the original equipment, your disposal cost is going to be a whole lot lower because you're not worrying about disposing of something that's got lead in it. That works for not only the equipment that's being taken off and replaced, but the work that you're doing. You've got scrap. If you're working in a radiator shop, you're cleaning that tin lead scrap off. So now you're worrying to make sure that your employees are safe, that they're not breathing in that lead dust, that they don't have food or drink in the work area where that lead dust might settle, that they're taking time to clean their hands thoroughly before they go and take their lunch break, because ingesting lead is the most common way for it to get into somebody's body. And so there's definitely ways that you can make your shop and your employees safer and save some money on disposal costs by making some of those switches as well.
You've been listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin. We've been speaking with Aaron Morrow, the general manager at the Johnson Manufacturing Company. To learn more about Johnson, visit johnsonmfg.com. Links are in the show notes. Aaron, thanks so much for being on the Heavy Duty Parts Report and giving me an education in solder and fluxes.
You're very welcome. I had a great time.
Thank you for watching this video. Click here to subscribe to the Heavy Duty Parts Report YouTube channel and click here to watch another great episode.